In the previous part of the lecture, we learned about why exposing the implementation details about either array or linked list and also their storing order to the clients is not a good idea because we violate the information hiding principle and also the single choice principle for maintenance. You really want to review that part if you haven't really got it yet. So now we want to see how we can solve the problem. It would be very nice to have a single view for the clients in the public, so it always remains stable, and then internally we can feel free to change from one implementation to another. So that's why math model can be useful. Before I get to the conceptual details, I want to show you how you can find details about math models yourself. So let me just turn this particular iPhone Studio project over here. So this particular source code is about the stack example that we did in the previous part of the lecture. It's being made available to you. It's called stack_math. So that's a project name. But any project will do because the math model has been set as a library by default. All you got to do is go to the libraries over here and go to math models over here. If you expand it, you'll see many classes over there. You can definitely feel free to explore them. We don't really talk about the graph sub-library for the math model, but it's quite an interesting library there. You can actually go there and see different graph algorithm, for example, topological sort. You can explore that for your own interest. But what I want to point to you is under collections, you want to explore at least about set, sequence, relation, pair, function, and also back. So these are the math model classes you should really get some idea. So later on, when you got an open quiz exam or open book quiz or open book exam, you will be able to find the information quickly. Also understand in general. Okay, but in the lab exercises, you will also be required to do one of them. Okay, but for now, let me just tell you where to find them. For example, for the lecture, we're going to use the sequence class, and then you can see all the features over here, which you will explore by yourself. We're just going to mention some of them just to give you the idea enough for you to do exploration yourself. Okay, let me move the iPhone Studio away, so now you already know how to find them. So let me just go back to the lecture. Okay, so let me just talk about conceptually how we can get things done, right? It would be very important to understand the two steps that we're going to do for the rest of this particular part of the lecture. So the first step is we want to create a single model view for all the three possible implementation strategies. And what do I really mean by a model? Model is really an abstraction. And abstraction really is about filtering out all the irrelevant details. Okay, by filter out details. Okay, what kind of details do we want to filter out? Well, for example, number one, we shouldn't really care about whether it's an array or it's a linked list. That's number one. And number two, we shouldn't worry too much about whether it should be the top should be at the end or the top should be at the front. Let's say we choose just one single view for all the users, for all the clients in the public. Okay. Also, the top, should it be actually the front or it should be the end? We shouldn't really get our clients confused. We should just choose one public view. So the model we're going to use, it will be a class from the math models library called sequence. So now, let's say from the client's point of view, it goes like this. Let's say we're going to create this particular public view for our clients over here. So this is basically called model. You can think about it as a model objects. Math models library just for you to create objects like in other classes. But now we're going to have just a model object over here of type sequence. And then you also notice that actually for our stack class is actually generic. So now we're also going to make the model generic. We talked about generic as well in the previous part of the lecture. So now for the model, let's say the following. We always want the last elements of the model to be the top. Let's say that's always the case, despite the underlying implementation. Even for strategy number 2, its corresponding model should still be the top, is still referring to the last element of the sequence. So now the conversion from the private implementation to the public model would be the key. Okay, so now let's see from the so now you want to think about for strategy number 1, we're going to somehow convert itself into the public model. And also for strategy number 2, it's also going to convert itself to this particular model. For strategy number 3, it's also going to convert itself to this particular model. This particular conversion process is called abstraction process. So it's going to be a conversion, and it's going to be done by something called abstraction function. Just we'll see that in a moment. By using an abstraction function. So we are promoting basically from array into a sequence. We are promoting from a linked list to a sequence. We are also promoting another linked list to a sequence as well. So the client is just going to have a unified view about the implementation, well, in the public, of course. So now, what about the view? Over here is always just going to be, in this case, Alan, and also Mark, and also Tom. Let's say this is in the pre-states. So in the pre-states, the client is going to understand your stack as this particular sequence where the last element of the sequence is always the top. Let's say we try to do some updates to the stack, right? So under the hood, let's say we are trying to do, let's say over here, let's say s.push. And then we actually got Jim over here. We want to push Jim into the stack. So now we actually will go from the pre-states. Let's say the blue one is the pre-states. Let's say the green one will be the post-states. So now the post-state is just going to be another sequence. The post-state will just be another sequence there. So now this will be the, you can think about this as like an old model over here, right? Conceptually. And this will be the new model. The new model will just be another model here from the client's point of view. So now it will be 4 elements over here, but the last element is always the top. So now they will think about Jim should be here. And the other 3, Alan, Mark, and Tom, should be here. Alan, Mark, and Tom, they should be here, right? So from the client's point of view, you're changing from one model sequence to another model sequence, and you can write a contract accordingly. Okay, so now there are 2 steps over here we want to do. I just want to draw the conceptual sketch for you for the 2 steps. Step number 1, we want to know how we can convert from individual strategy into a model sequence. That's step number 1. Step number 2, once we know that from the client's point of view, they only understand about sequences rather than linked list or array. They only understand about model over here. So when you go from one pre-state model into another post-state model, how should we write a post condition to draw their relationship? So that's the step number 2. Okay, so now let me write it down over here. So there are 2 steps that we have to worry about. Number 1 is about promoting implementation to model using abstraction function, which I'll show you in just one slide in detail. And number 2, it's about writing contracts. Write contracts in terms of models rather than in terms of the implementation, which could be an array, or it could be a linked list, or it can be of different order. So that's really the 2 steps we want to satisfy. Okay, number 1 and number 2. Okay, just make sure you understand conceptually, and then we're going to elaborate on details for these 2 steps. Before I talk about the first step in detail, let's say what kind of routines do we need for either step 1 or step 2. For step number 1, because you're doing some conversion, so in order for me to convert from an array into a mathematical sequence, I will need commands to keep adding to the sequence. So that will be using commands from the math model library. On the other hand, for step number 2, if I want to write contracts in terms of the sequences in the pre-state and post-states, because in the contracts, it is supposed to be a Boolean expression, so I cannot use any commands. I need to use queries that will somehow return values for me to compare against. So for number 1, I need to use commands. For number 2, I need to use queries. And we know pretty well the difference between queries versus command, right? Okay, just keep that in mind. So now for step number 1, so I don't need to go back to slides at the moment. I'm just describing all the details over here. But I will just tell you how you should read the slides in a moment. But you can do it by yourself. So now for step number 1, we want to implement the so-called abstraction function over here. So we want to basically promote from your implementation, which might be array, linked list, hash table, whatever, from internal into some external public abstraction for the clients. In this case, the model. Okay. So let's see how we can do it. A very standard way of doing it is we declare this particular model, which is the abstraction function. Okay, so this is the abstraction function that we are going to declare. Okay, and then it's of type sequence of G over here. And remember, our level stack over here is generic over here. Okay, and then so here is just using the same G. So whatever G we declare, which could be string, account, integer, the G will be changed accordingly, right? That's what we said before. So model is simply a sequence of elements, and then this is the implementation here. Okay, let's see what this really means. Okay, so this is saying result, which is of type sequence of G, just a sequence. Okay, I'm gonna ignore the G for now. Result is simply the return type over here, which is a sequence. Initially, it will simply just be empty. So just empty over here. And now we are going to go across the implementation. Well, let's talk about, so now we're talking about strategy number 3, right? For strategy number 3, let me go back here. For strategy number 3 is actually a linked list of 3 elements, right? Alan, Mark, and Tom. So in total, we're going to have 3 iterations, right? So now you can think about implementation. Let me just draw that quickly. So we have the implementation, which is pointing to a linked list of 3 elements for us. Okay, and then it's going to be of order Alan, Mark, and Tom. I'll just say Alan, Mark, and Tom over here. That's the implementation. And when we actually say stack, so one thing you should really notice is this. Okay, let me just draw a little bit more complete picture for you. At the runtime, let's say we have stack s of type stack of whatever type. Let's say string. Let's say, since we talk about names. So at the runtime, S is pointing to some stack objects where it has at least 2 fields you should really worry about. One is about the implementation, which will be this particular linked list. So you should think about this is the implementation. Also, you got another query that you can call, which is model. And the model is really something we are trying to create over here conceptually, right? Model is not really an attribute, so just like a query that can be called upon demand. Okay, so now how do we actually do this particular model over here, right? Let's see over here. Whenever we say s.model over here, right, it's a query without any parameters. What it's going to do is it's going to, first of all, before we run the across loop, it's going to create something that's empty. So initially just empty. And we know that we're going to run 1, 2, and 3 iterations in total, right? For the very first iteration, so here I'm just using s for the across, but you should really do the corresponding version in is. Doesn't matter. So every time we're going to say result.append and then cursor the item over here. So now for the very first iteration, the cursor will be pointing to Alan, right? So when we append is like inserting to the end. So this is actually a command from sequence. The sequence clause. You can look it up in Eiffel Studio. As I said before, for step number 1, when you define the abstraction function, when you do the conversion, you will need commands from the math models library. So now it will be append. So now for the very first iteration, we're gonna simply append a to the end of the sequence. So now after the first iteration, this is the sequence we got. Well, what about for the second iteration? For the second iteration, we're going to, the cursor will be pointing to here, and then we're gonna append again. So now you will append to the end of the model, that will be Mark. And then for the third iteration, cursor will be pointing to the third one over here. And then Tom. Of course, for illustration purpose, I'm drawing Alan, Mark, and Tom as different string objects. But at the runtime, if they might just point to the same object, depending on the specifics of your implementation. I'll leave that a little bit open here. But conceptually, the pink one over here is really the model we are creating after calling this particular abstraction function. The way you call that is by saying stack s.model, right? Don't get confused. For stack object, it simply contains implementation, which is a linked list. That one's hidden, it's private. However, the public query client can call will be s.model. So let me make it very clear to you. So over here, the pink one over here is public, and over here, the green one over here is private. Okay, just be consistent with color here. So now let's talk about two important exercises for you to do before you proceed, right? I already talked about in order to convert from strategy number 3 over here, this particular linked list into the public model, how you would do it. So now what about other strategies? For example, now if I determine that I want to do strategy number 2, for example, strategy number 2 would be in the reverse order. So now, in order to create the same public view, that would be Alan, Mark, and Tom, rather than Tom, Mark, Alan. So what should I change over here? This line must be changed. So that will be your exercise 2. I'll talk about exercise 2 first. So what should you change? I'll give you a little bit hints. You may want to change from append to something else. Look up the features in the sequence class in the math model and you will find the answer. Okay, that will be an exercise for you. You want to do it? Otherwise, you can ask me in the Q&A session. So now exercise number 1 will be also important just to link what we did previously. So now, in order for you to really make sure this particular model conversion function is really implemented correctly, let's say over here, what if I have an ensure over here, post condition. So now the result is simply just a sequence over here, right? So now the result should be somehow related to the imp, which can be either linked list or array. So the idea would be this is the only place that you will talk about implementation. I want to link. I want to draw the relation between the result, which is a public model view, and also the underlying implementation. That's the only place you will expose the detail. That's the only place. Okay, and then all other queries or commands like a push and pop and also top, they will not refer to imp anymore. They will only refer to just model. So that's something I will summarize a little bit later. Okay, so now these two exercises, I'm not going to give you the answer right now, but you're going to do them. Okay, if you don't ask me, I will presume you're okay. Right? Please do it. Okay, that's about step number 1, which is how we convert from a particular implementation into the math models. So now we want to go to step number 2, which is also important. For step number 2, it's about writing contracts using the model. Okay, assuming that model has been implemented correctly for the abstraction function, assuming that's the case. So now we want to say, for example, how do we do it? We just talk about the details of how you can implement this particular public query for the stack, which is model, right? So now for every other query or command, remember I said before, for this model, that's the only place that you actually draw a relation between imp and also the result. But all other places, when you say, for example, push. So now in order to do push, we don't want to write a post condition like how we did it before, like using imp, because that will violate information hiding and also single choice principle. What we want to do instead is something like this. Let me highlight it. I will explain to you in a separate slide in detail. We're going to say model here. Okay, you can think about we're basically making two calls to the same model query. Think about this particular call is like the pre-states, and this particular call is the post-states, and then we want to draw a relationship between them. Think about this is like a call to in the post-states after the push. And this particular, because we are using the old keywords, so this is in the pre-states. Okay, so now there will be a very important question to ask over here. Okay, so remember we have the same public view about the model. Okay, so it's always the end of the sequence will be the top of the stack, right? That's all, the top of the stack will be the end of the sequence. That's always the case. Okay, so now the question will be over here. Can clients tell which strategy is being adopted? All the clients can see will be just this particular contract over here as opposed to before. Before they will see imp, for example, at the first, when they will say imp at position count. In that case, they will be able to tell how you implement the stack. But now we only say model and model over here. Can you actually tell what the underlying implementation is? Not really, because remember the imp is exported to none. That means it's private. And now we're only using model over here, which might be promoted from either an array or the linked list. So we don't really know. Okay, the answer is no, which is a good thing. No. So that means we have information hiding is satisfied. Information hiding is actually satisfied. Okay, and then what if strategy was changed? Change what? Right? So now let's say we will always have this particular contract always. So this contract here, which is public, will always stay stable. Okay. So now when we change, that will be basically the same question as before. What if we change from strategy number 3 into, let's say, strategy number 2? So what do we change? We definitely don't have to change this particular contract. It should always remain the same for push. The only thing we change is basically exercise number 2 that I said to you before, right? In that case, you may want to modify just, for example, this particular command. Rather than inserting to the end, maybe you want to do the opposite order. Okay, that's the only place you have to change. Let me write it down here. And then I will explain to you how to check this particular contract in detail. So, what if strategy was changed? Only change the abstraction function model. Only change the abstraction function, i.e. the implementation and potentially also the contract for model. Right? You may reverse the order, in which case the relationship between result and also the end will also be reversed. Right? So these are the this is an important question here, and then there's an exercise that you may have to do. This exercise is really related to exercise number 2 from before. Okay, just make sure you do that.